is the only difference between these two is just a shift, right? If you take a look at your close graph, just add 9 degrees to the right, it's going to be sine, right? That's the only real difference. And again, you guys all have this drawn in painstaking detail, right? Like every 30 degrees, right? So you just know the power of that graph that are ingrained in your soul forever, right? But Jake? Good. Jake, here are my 4 pieces of information. What I want you to do for the transformations, I want you to think back to the f of x thing. Remember we did the f of x transformations earlier in the year, like stretches and all that sort of stuff. The a is the number in front of the bracket. So let's say I do a sine of 3x. Y equals, we'll do something for a sec while this is on. If I go yay math, you guys go back yay math. Yay math!
Yay math!
Okay, good. Okay, back to this here. So if we have 3 sine of theta, what's that going to change? If it's 3 sine of theta, yeah, the amplitude is going to be 3. It's going to stretch the graph. So A is going to be your amplitude. And if you have a hard time, you don't have to memorize this equation. This is going to be just like the f of x stuff. All that means is multiply your y values by 3. The y values happen to be your amplitude. That's all it is. What was K? Let's say I do sine 2 theta. What's that going to do for us?
Period.
Yeah, it's going to factor period. Okay. I'm going to call this the multiplier actually. And you notice I left a little bit of space in there. I want you to do the same because I want to change this a little bit. Okay, if it says sine of 2 theta, what did that mean before? If you do like f of 2x, what did f of 2x tell you to do? Sorry? Divide your x by 2, right? So sine of 2 theta is going to be what then? Your period. Divided by your 2, so 180. So the period is going to be 360 divided by k. Does that make sense, right? That's going to be what the factor is expressed. I'm also going to make something else called action points. And we'll get to these on the graph in a sec. What an action point is, it's going to be 90 over k as a definition. Okay, but an action point is, to look back to the graph on the left here, when the graph goes from the middle to the top, to the middle to the bottom, it's just called an action point. So instead of graphing every 30 degrees like I made you, we're just going to graph every 90 on the straight graph. It's going to be, again, and maybe I'll write that on the next board here. Action points are when the graph goes from max to axis to min, etc. And I should probably give it a better name because I created that name myself. Some teachers call them quarter points. Mr. Kemp actually calls them action points. I should have called them Sadler points, but I chose not to. It's called action points. Okay, B. If I take a look at it, we did the old days, f of x plus 3. What was f of x plus 3? F of bracket x plus 3. Bracket x. Right on. So that would be a horizontal shift, right? So I'm going to call this, B is going to be your phase shift. No. And I'm going to talk about how we do all these. I'll guess at the beginning of tomorrow's class, I'll go through making equations to do the graph. So I'm going to make sure you guys can graph well. It says in opposite shift, that should say in opposite direction. Okay, so once again, if it's so just like how that's the direction, not director. If you, just like before, I'm doing f of x plus 3 instead of adding 3 to x to the left. Okay, just all good to the left. Okay, to show me how much you know, what is the last, what's the d then? No. Okay, in English though, what's the d? If I did f of bracket x and I said plus 3, what would you do then? Right? Add 3 to your y. So you're going to shift the entire graph up and down with the vertical shift and call that my axis. Okay. Those are the big ones to know. So we're going to graph one of these today, maybe 2 if we have the time, and then we're going to stop. And then I'm going to, hopefully we'll get on to making equations, which I'll probably do. Stop.